Welcome. Today's section or lesson is going to be section 3D-B. We're talking about spheres. And so we've already done spheres in chapter 9, so this should be kind of a review. So hopefully this will be quick and easy for you. So spheres. A sphere is a set of points at a given distance called the radius from a given point called the center. Okay. And I've already kind of stated the equation for the sphere, which is x minus h squared plus y minus k squared plus z minus l squared is equal to r squared. So if you were talking about the traces like we did for the ellipsoid in the last lesson, here all your traces would be circles. And then that's how you get the sphere's shape. Now, your center is going to be the HKL and your radius is the r. Okay? So here, if I want to be able to write an equation for a sphere, given some kind of conditions, you're given the center and then you're given a point that the sphere actually passes through. So using those 2 points, you can use the distance formula to help you find what r should be. Okay, so r should equal, which is the distance between the two, like the definition states. Here you got, and it doesn't matter the order which you do this in, so negative 3 minus the negative 2 squared plus 7 minus 5 squared plus 2 minus 7 squared. Okay? And so double negative makes it positive. So that gives me negative 1 squared. That gives me 2 squared, and that gets me negative 5 squared. So squaring those gets me 1, gets me 4, and gets me 25. So together, your radius should be square root of 30. Okay? So now using that and your point, you can plug in your point and your radius to get. Now remember, because there's minuses, they're always the opposite, so it's x plus 2, not x minus 2 squared, plus y minus 5 squared, plus z minus 7 squared, and then your square root of 30 squared. You can simplify your radius. And then that gives us the following equation. And that's the equation for your sphere. Okay? So that would be one example of that. Here, there'll be other questions on your assignment which ask you to put this equation in standard form, which we've done before with Chapter 9, so this is just a review as well. But then also describe it. Now, describing doesn't mean really saying anything profound. It's just mostly stating what your center and your radius is for the sphere. And so describing it is just describing the important items is what they're asking. Okay, so here you want to group all your stuff. So 3x squared minus 60x, and then 3y squared plus 12y, and then 3z squared minus 24z. You also want to move this 39 to the other side because you do not want it, because it's not going to help you with your perfect squares anyway. Okay, so now you want to put them in parentheses and factor out the good stuff, so let's do that. So 3 would come out of this first one. So then negative 60x would become negative 20x. And then you leave a plus blank. And then factor out your 3 for your y squared. So that leaves you with 4y. And then pull out a 3 as well. So that gives you negative 8z. Now you're probably wondering, why do all the coefficients for all the squares are the same? That's what makes it a sphere in this case, is because the coefficient, or leading coefficient for each square value is the same. Because if they were different, that would make it an ellipsoid or an ellipse for your traces, which is not the picture that we're looking for. Since we're looking for a sphere, you want all your traces to be circles. So that's one of those indications that makes it a sphere, is that all those coefficients are exactly the same. Okay? So finish this off. But we want to be able to add stuff to this. Okay? So here, half of negative 20 is negative 10. Square that gives you 100. Okay? A half of 4 is 2. Square that, it's 4. And then, how about we put that in a different color? So you can kind of see that we're adding that. And then half of negative 8 is negative 4 squared is 16. Okay? Now, before you move it to the other side, you have to multiply it to the 3, because if you distribute the 3 through, 100 would be 300. So if you just put 100, then you wouldn't actually be making both sides of your equation balanced. And so 4 times 3 gets you 12, and then 16 times 3 gets you 48. Okay? And so now you can condense all of your trinomials into a binomial squared. So you get 3 times x minus 10 squared plus 3 times y plus 2 squared plus 3 times z minus 4 squared. And now negative 39 plus 300 plus 12 plus 48 would actually gets us 321. And so now you want to get rid of the 3's in front, because that's not really standard form. So divide everything by 3. So x minus 10 squared plus y plus 2 squared plus z minus 4 squared will equal 107. And so that's my standard form. And then I want to be able to describe this, so I have a sphere with radius, or with a center of 10, comma negative 2, comma 4, remember they're always the opposite, and a radius of square root of 107. And you can just leave it like that. If it's a radical, you can choose to put it in decimal form, but radical is just fine. It's not a big deal. Unless it reduces, make sure it reduces. So if it was like square root of 100, you would say it's a radius of 10. Okay? And that's it. Have fun.